Third iteration. Details emerge more clearly as the fractal curve is redrawn. Ian Malcolm. Jurassic Park. They moved into a green tunnel of overarching palms leading toward the main visitor building. Everywhere, extensive and elaborate planting emphasized the feeling that they were entering a new world. A prehistoric tropical world, and leaving the normal world behind. Ellie said to Grant, "They look pretty good." "Yes," Grant said. "I want to see them up close. I want to lift up their toe pads and inspect their claws and feel their skin and open their jaws and have a look at their teeth. Until then, I don't know for sure, but yes, they look good." "I suppose it changes your field a bit," Malcolm said. Grant shook his head. It changes everything," he said. For 150 years, ever since the discovery of gigantic animal bones in Europe, the study of dinosaurs had been an exercise in scientific deduction. Paleontology was essentially detective work, searching for clues in the fossil bones and the trackways of the long-vanished giants. The best paleontologists were the ones who could make the most clever deductions. And all the great disputes of paleontology were carried out in this fashion, including the bitter debate, in which Grant was a key figure, about whether dinosaurs were warm-blooded. Scientists have always classified dinosaurs as reptiles, cold-blooded creatures drawing the heat they needed for life from the environment. A mammal could metabolize food and produce bodily warmth, but a reptile could not. Eventually, a handful of researchers, led chiefly by John Ostrom and Robert Bakker at Yale, began to suspect that the concept of sluggish, cold-blooded dinosaurs was inadequate to explain the fossil record. In classic deductive fashion, they drew conclusions from several lines of evidence. First was posture. Lizards and reptiles were bent-legged sprawlers, hugging the ground for warmth. Lizards didn't have energy to stand on their hind legs for more than a few seconds, but the dinosaurs stood on straight legs, and many walked erect on their hind legs. Among living animals, erect posture occurred only in warm-blooded animals and birds. Thus, dinosaur posture suggested warm-bloodedness. Next, they studied metabolism, calculating the pressure necessary to push blood up the 18-foot-long neck of a brachiosaur, and concluding that it could only be accomplished by a 4-chambered hot-blooded heart, in a frigid environment unimaginable for a reptile. And the new studies of group behavior, based largely on Grant's own work, suggested that dinosaurs had a complex social life and reared their young, as reptiles did not. Turtles abandoned their eggs, but dinosaurs probably did not. The warm-blooded controversy had raged for 15 years before a new perception of dinosaurs as quick-moving, active animals was accepted, but not without lasting animosities. At conventions, there were still colleagues who did not speak to one another, but now, if dinosaurs could be cloned, why, Grant's field of study was going to change instantly. The paleontological study of dinosaurs was finished. The whole enterprise, the museum halls with the giant skeletons and flocks of echoing schoolchildren, the university laboratories with their bone trays, the research papers, the journals, all of it was going to end. "You don't seem upset," Malcolm said. Grant shook his head. "It's been discussed, and in the field many people imagined it was coming, but not so soon." "Story of our species," Malcolm said, laughing. "Everybody knows it's coming, but not so soon." As they walked down the path, they could no longer see the dinosaurs, but they could hear them, trumpeting softly in the distance. Grant said, "My only question is, where did they get the DNA?" Grant was aware of serious speculation in laboratories in Berkeley, Tokyo, and London that it might eventually be possible to clone an extinct animal such as a dinosaur, if you get some dinosaur DNA to work with. The problem was all the known dinosaurs were fossils, and the fossilization destroyed most DNA, replacing it with inorganic material. Of course, if a dinosaur was frozen, or preserved in a peat bog, or mummified in a desert environment, then its DNA might be recoverable. But nobody ever found a frozen or mummified dinosaur, so cloning was therefore impossible. There was nothing to clone from. All the modern genetic technology was useless. It was like having a Xerox copier, but nothing to copy it with. Ellie said, "You can't reproduce a real dinosaur because you can't get real dinosaur DNA. "Unless there's a way we haven't thought of," Grant said. "Like what?" she said. "I don't know," Grant said. Beyond a fence, they came to the swimming pool, which spilled over into a series of waterfalls and smaller rocky pools. The area was planted with huge ferns, Isn't this extraordinary? Yadri just said. Especially on a misty day. These plants really contribute to the prehistoric atmosphere. These are authentic Jurassic ferns, of course. Ellie paused to look more closely at the ferns. Yes, it was just as he said. Serena veriformans, a plant found abundantly in fossils more than 200 million years ago. Now common only in the wetlands of Brazil and Colombia. But whoever had decided to place this particular fern at poolside obviously didn't know what the spores of veriformans contained. A deadly beta-carboline alkaloid. Even touching the attractive green fronds could make you sick. And if a child were to take a mouthful, he could almost certainly die. The toxin was 50 times more poisonous than oleander. People are so naive about plants, Ellie thought. They just chose plants for appearance, as they could choose a picture from a wall. It never occurred to them that plants were actually living things, busily performing all the living functions of respiration, ingestion, excretion, reproduction, and defense. But Ellie knew that. In the Earth's history, plants had evolved as competitively as animals, and in some ways, more fiercely. The poison in Serena veriformans was a minor example of the elaborate chemical arsenal of weapons that plants had evolved. There were terpenes, which plants spread to poison, to soil around them, to inhibit competitors, alkaloids, which made them unpalatable to insects and predators, and children, and pheromones used for communication. When Douglas fir tree was attacked by beetles, it was produced an anti-feeding chemical, and so did other Douglas firs in distant parts of the forest. It happened in response to a warning alchemical secreted by the trees that were under attack. People who imagined that life on Earth consisted of animals moving against a green background seriously misunderstood what they were seeing. That green background was busily alive. Plants grew, moved, twisted, and turned, fighting for the sun, and they interacted continuously with animals, discouraging some with bark and thorns, poisoning others, and feeding still others to advance their own reproduction, to spread their pollen seeds. It was a complex dynamic process which she never ceased to find fascinating, and which she knew most people simply didn't understand. But if planting deadly ferns at poolside was any indication, then it was clear that the designers of Jurassic Park had not been as careful as they should have been. Isn't it just wonderful? Ed Regis was saying. If you look up ahead, you'll see our safari lodge. Ellie saw a dramatic, low building with a series of glass pyramids on the roof. That's where you'll all be staying here in Jurassic Park. Grant's suite was done in beige tones, the rattan furniture and green jungle print motifs. The room wasn't quite finished. There were stacks of lumber in the closet and pieces of electric conduit on the floor. There was a television set in the corner with a card on top. Channel 2, Hypsilphodont Highlands. Channel 3, Triceratops Territory. Channel 4, Sauropod Swamp. Channel 5, Carnivore Country. Channel 6, Stegosaurus South. Channel 7, Velociraptor Valley. Channel 8, Pterosaur Peak. He found the names irritatingly cute. Grant turned on the television but got only static. He shut it off and went to his bedroom, tossed his suitcase on the bed. Directly over the bed was a large pyramidal skylight. It created a tented feeling, like sleeping under the stars. Unfortunately, the glass had to be protected by heavy bars so that the striped shadows fell across the bed. Grant paused. He had seen the plans for the lodge, and he didn't remember bars on the skylight. In fact, these bars appeared to be rather crude addition. A black steel frame had just been constructed outside the glass walls, and the bars welded to the frame. Puzzled, Grant moved from the bedroom to the living room. His window looked out on the swimming pool. By the way, those ferns are poison, Ellie said, walking into his room. But did you notice anything about the rooms, Alan? They changed the plans. I think so, yeah. She moved around the room. The windows are small, she said, and the glass is tempered, set in a steel frame. The doors are steel-clad. That shouldn't be necessary. And did you see the fence when we came in? Grant nodded. The entire lodge was enclosed within a fence, with bars of inch-thick steel. The fence was gracefully landscaped and painted flat black to resemble wrought iron, but no cosmetic effort would disguise the thickness of the metal over its 12-foot height. I don't think the fence was in the plans either, Ellie said. It looks to me like they would turn this place into a fortress. Grant looked at his watch. Be sure to ask why, he said. The tour starts in 20 minutes. When Dinosaurs Ruled the Earth. They met in the visitor building 2 stories high, and all glass with exposed black anodized girders and supports. Grant found it determinedly high-tech. There was a small auditorium dominated by a robot Tyrannosaurus Rex, poised menacingly by the entrance to the exhibit area labeled, "When Dinosaurs Ruled the Earth." Farther on were other displays. "What is a dinosaur?" and "The Mesozoic World," and exhibits were completed. There were wires and cables all over the floor. Jannar climbed up the stage and talked to Grant, Ellie, and Malcolm, and his voice echoing slightly in the room. Hammond sat in the back, his hands folded across his chest. "We're about to tour the facilities," Jannar said. "I'm sure Mr. Hammond and his staff would show everything in the best light. Before we go, I want to review why we're here, and what I need to decide before we leave. Basically, as you all realize by now, this is an island in which genetically engineered dinosaurs have been allowed to move in a natural park-like setting, forming a tourist attraction. The attraction isn't open to tourists yet, but it will be in a year. Now, my question for you is a simple one. Is this island safe? Is it safe for visitors? And is it safely containing the dinosaurs?" Jannar turned down the room lights. "There are 2 pieces of evidence in which we have to deal with first. First of all, there's Dr. Grant's identification of a previously unknown dinosaur in the Costa Rican mainland. This dinosaur is known only from a partial fragment. It was found in July of this year after it supposedly bit an American girl on the beach. Dr. Grant can tell you more later. I've asked for original fragment, which is in the lab in New York, to be flown here so we can get it inspected directly. Meanwhile, there's a second piece of evidence. Costa Rica has an excellent medical service, and it tracks all kinds of data. Beginning in March, there were reports of lizards biting infants in their cribs, and also, I might add, biting old people who were sleeping soundly. These lizard bites were sporadically reported in coastal villages from Isamaloya to Punta Arenas. After March, lizard bites were no longer reported. However, this graph from Public Health Service in San Jose of infant mortality in the towns of the West Coast earlier this year. I direct your attention to 2 features of this graph. Firstly, infant mortality is low in the months of January and February, then spikes in March, then it's low again in April. But from May onward, it's high, right through July, the month the American girl was bitten. The Public Health Service feels that something is now affecting infant mortality, and it's not being reported by the workers in the coastal villages. The second feature is the puzzling bi-weekly spike, which seems to suggest some kind of alternating phenomenon is at work. The lights came back on. "Alright," Jannar said. "That's the evidence I want explained. Now, are there any—" "We can save ourselves a great deal of trouble," Malcolm said. "I'll explain it for you now." "You will?" Jannar said. "Yes," Malcolm said. "First of all, animals are very likely gotten off the island." "Oh, balls!" Hammond growled from the back. "And second, the graph in the Public Health Service is almost certainly unrelated to the animals that have escaped." Grant said, "How do you know that?" "You'll notice that the graph alternates between high and low spikes," Malcolm said. "That is characteristic of the complex systems. For example, water dripping from a tap. If you turn on the faucet just a little, you'll get a constant drip, drip, drip. But if you open it a little more, so there's a bit of turbulence to the flow, then you'll get an alternating large and small drops. Drip, 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 like that. You can try it yourself. Turbulence produces alternation in its signature, and you will get an alternating graph like this for the spread of a new illness in a community." "But why do you say it isn't caused by escaped dinosaurs?" Grant said. "Because it's a non-linear signature," Malcolm said. "You need hundreds of escaped dinosaurs to cause it, and I don't think hundreds of dinosaurs have escaped, so I conclude that some other phenomenon, such as a new variety of flu, is causing the fluctuations you see on the graph." Jannar said, "But you think that dinosaurs have escaped?" "Probably, yes." "Why?" "Because of what you're attempting here. Look, this island is an attempt to recreate a natural environment from the past. To make an isolated world where extinct creatures roam freely, correct?" "Yes." "But from my point of view, such an undertaking is impossible. The mathematics are so self-evident that they don't need to be calculated. It's rather like my asking whether on $1 billion in income, you'd have to pay tax. Fucking hell. You wouldn't need to pull out your calculator to check. You'd know tax was owed. And similarly, I know overwhelmingly that one cannot successfully duplicate nature in this way or hope to isolate it." "Why not? After all, there are zoos—" Zoos don't recreate nature, Malcolm said. Let's be clear. Zoos take the nature that already exists and modify it very slightly to create holding pens for animals. Even those minimal modifications often fail. The animals escape with regularity, but a zoo is not a model for this park. This park is attempting something far more ambitious than that. Something that is more akin to making a space station on Earth. Gennaro shook his head. I don't understand. Well, it's very simple. Except for the air, which flows freely, everything about this park is meant to be isolated. Nothing gets in, nothing out. The animals kept here are never to mix with the greater ecosystems of Earth. They are never to escape. And they never have, Hammond snorted. Such isolation is impossible, Malcolm said flatly. It simply can't be done. It can. It's done all the time. I beg your pardon, Malcolm said, but you don't know what you're talking about. You arrogant little snot, Hammond said. He stood and walked out of the room. Gentlemen, Gennaro said. I'm sorry, Malcolm said, but the point remains. What we call nature is in fact a complex system of a far greater subtlety that we are willing to accept. We make a simplified image of nature and then we botch it up. I'm no environmentalist, but you have to understand what you don't understand. How many times must the point be made? How many times must we see the evidence? We build an Aswan dam and claim it's going to revitalize the country. Instead, it destroys the fertile Nile Delta, produces parasitic infestation, and wrecks the Egyptian economy. We build the... Excuse me, Gennaro said, but I think I hear the helicopter. That's probably the sample for Dr. Grant to look at. He stared out of the room. They followed. At the foot of the mountain, Gennaro was screaming over the sound of the helicopter. The veins of his neck stood out. You did what? You invited who? Take it easy, Hammond said. Gennaro screamed, Are you out of your goddamn mind? Now look here, Hammond said, drawing himself up. I think we have to get something clear. No, Gennaro said. No, you get something clear. This is not a social outing. This is not a weekend excursion. This is my island, Hammond said, and I can invite whomever I want. This is a serious investigation of your island because your investors are concerned that it's out of control. We think this is a very dangerous place, and you are not going to shut me down, Donald. I will if I have to. This is a safe place, Hammond said, no matter what the damn mathematician is saying. It's not. And I'll demonstrate its safety. And I want you to put them right back on that helicopter, Gennaro said. Can't, Hammond said, pointing toward the clouds. It's already leaving, and indeed the sound of the rotors were fading. God damn it, Gennaro said. Don't you see you're needlessly risking... Hammond said. Let's continue this later. I don't want to upset the children. Grant turned and saw two children coming out of the hillside led by Ed Regis. There was a bespectacled boy of about 11 and a girl a few years younger, perhaps 7 or 8. Her blonde hair pushed under the Mets baseball cap, and a baseball glove slung over her shoulder. Two kids made their way nimbly down the path from the helipad and stopped some distance from Gennaro and Hammond. Low under his breath, Gennaro said, Christ! Now, take it easy, Hammond said. Their parents are getting a divorce. I want them to have a fun weekend here. The girl waved tentatively. Hi, Grandpa, she said. We're here. The tour. Tim Murphy could see at once that something was wrong. His grandfather was in the middle of an argument with the younger, red-faced man opposite him, and the other adults standing behind looked embarrassed and uncomfortable. Alexis felt the tension too, because she hung back, tossing her baseball in the air. He had to push her. Go on, Lex. Go on yourself, Timmy. Don't be a worm, he said. Lex glared at him, but Ed Regis said cheerfully, I'll introduce you to everybody, and then we can take the tour. I have to go, Lex said. I'll just introduce you first, Ed Regis said. No, I have to go. But Ed Regis was already making introductions. First to Grandpa, who kissed them both, and then to the man who he was arguing with. This man was muscular, and his name was Gennaro. The rest of the introductions were a blur to Tim. There was a blonde woman wearing shorts, and there was a man with a beard who wore jeans and a Hawaiian shirt. He looked like the outdoors type. Then a fat college kid who had something to do with computers, and finally a thin man in black who didn't shake hands, but just nodded his head. Tim was trying to organize his impressions, and was looking at the blonde woman's leg when he suddenly realized that he knew who the bearded man was. "Your mouth is open," Lex said. Tim said, "I know him." "Oh sure, you just met him." "No," Tim said, I have his book." The bearded man said, "What book is that, Tim?" "Lost World of the Dinosaurs," Tim said. Alexis snickered. "Daddy says Tim has dinosaurs on the brain," she said. Tim hardly heard her. He was thinking of what he knew about Alan Grant. Alan Grant was one of the principal advocates of the theory that dinosaurs were warm-blooded. He had done lots of digging at the place called Egg Hill in Montana, which was famous because of so many dinosaur eggs that he found there. Professor Grant had found most of the dinosaur eggs that had ever been discovered. He was also a good illustrator and drew the pictures for his own books. "Dinosaurs on the brain," the bearded man said. "Well, as a matter of fact, I have that same problem." "Dad says dinosaurs are really stupid," Lex said. "He says Tim should get out in the air and play more sports." Tim felt embarrassed. "I thought you had to go," he said. "In a minute," Lex said. "I thought you were in such a rush." "I'm the one who would know. Don't you think, Timothy?" she said, putting her hands on her hips, copying her mother's most irritating stance. "Tell you what," Ed Regis said. "Why don't we all just head over to the visitor center and we can begin our tour?" Everybody started walking. Tim heard Gennaro whisper to his grandfather, "I could kill you for this!" And then Tim looked up and saw that Dr. Grant had fallen into the step beside him. "Oh, how old are you, Tim?" 11. "How long have you been interested in dinosaurs?" Grant said. Tim swallowed. A while now," he said. He felt nervous to be talking to Dr. Grant. "We go to museums sometimes when I can talk my family into it. My father..." Your father's not especially interested." Tim nodded and told Grant about his family's last trip to the Museum of Natural History. His father looked at the skeleton and said, "That's a big one." Tim had said, "No, Dad, that's a medium-sized one. A Camptosaurus." "I don't know. Looks pretty big to me." "It's not even fully grown, Dad." His father squinted at the skeleton. "What is it, Jurassic?" "Jeez, no, Cretaceous." "Cretaceous? What's the difference between Cretaceous and Jurassic?" "Only about 100 million years," Tim said. "Cretaceous is older?" "No, Dad, Jurassic is older." "Well," his father said, stepping back, "looks pretty damn big to me." And he turned to Tim for an agreement. Tim knew he had better agree with his father, so he just muttered something and they went on to another exhibit. Tim stood in the front of one skeleton, a Tyrannosaurus Rex, the mightiest predator the Earth has ever known for a long time. Finally, his father said, "What are you looking at?" I'm counting the vertebra," Tim said. "The vertebra?" "In the backbone." "I know what vertebra are," his father said, annoyed. He stood there a while longer, then he said, "Why are you counting them?" "I think they're wrong. Tyrannosaurus should only have 37 vertebrae in the tail. This has more." "You mean to tell me," his father said, "that the Museum of Natural History has the skeleton thing wrong? Can't believe that." "It's wrong," Tim said. His father stomped off toward a guard in the corner. "What did you do now?" his mother said to Tim. "I didn't do anything. I just said the dinosaur is wrong, that's all." And then his father came back with a funny look on his face because of course the guard told him that the Tyrannosaurus had too many vertebrae in the tail. "How did you know that?" his father asked. "I read it," Tim said. "That's pretty amazing, son," he said, and he put his hand on his shoulder, giving him a squeeze. "You know how many vertebrae belong in that tail. I've never seen anything like it. You really do have dinosaurs on the brain." Then his father said he wanted to catch the last half out of the Mets game on TV. And Lex said she did too, so they left the museum. And Tim didn't see any other dinosaurs, which was why they had come there in the first place. But that was how things happened in his family. How things used to happen in his family, Tim corrected himself. Now that his father was getting a divorce from his mother, things would probably be different. His father already moved out, and even though it was weird at first, Tim liked it. He thought his mother had a boyfriend, but couldn't be sure, and of course, he would never mention it to Lex. Lex was heartbroken to be separated from her father, and in the last few weeks she'd become so obnoxious that... "Was it 5027? Grant said. "I'm sorry?" Tim asked. "The Tyrannosaurus at the museum, was it 5027? Yeah, Tim said. "How did you know?" Grant smiled. "They've been talking about fixing it for years, but nope, it never happened." "Why's that?" "'Cause of what's taking place here," Grant said, "on your grandfather's island." Tim shook his head. He didn't understand what Grant was talking about. "My mom said it was just a resort, with like swimming and tennis." "Not exactly," Grant said. "I'll explain as we walk along." "Now I'm a damn babysitter," Ed Regis thought unhappily, tapping his foot as he waited in the visitor center. That was what the old man had told him. "You watch my kids like a hawk. They're your responsibility for the weekend." Ed Regis didn't like it at all. He felt degraded. He wasn't a damn babysitter, and for that matter, he wasn't a damn tour guide, even for VIPs. He was the head of public relations for Jurassic Park, and he had so much to prepare between now and the opening. A year away just to coordinate with the PR firms in San Francisco and London and the agencies in New York and Tokyo was a full-time job, especially since the agencies couldn't yet be told what the resort's real attraction was. The firms were all designing teaser campaigns, nothing specific, and they were unhappy. Creative people needed nurturing. They needed encouragement to do their best work. He couldn't waste his time taking scientists on tours. But that was the trouble with a career in public relations. Nobody saw you as a professional. Regis had been down here on the island off and on for the past 7 months, and they were still pushing odd jobs on him. Like that episode back in January, Harding could have handled that. Harding or Owens, the general contractor, instead had fallen to Ed Regis. What did he know about taking care of some sick workmen? And he was a damn tour guide and babysitter? He turned back and counted the heads. Still one short. Then in the back, he saw Dr. Sattler emerge from the bathroom. "Alright, folks, let's begin our tour of the second floor." Tim went with the others, following Mr. Regis up the black suspended staircase to the second floor of the building. They passed a sign that read, "Closed area. Authorized personnel only beyond this point." Tim felt a thrill when he saw that sign. They walked down a second-floor hallway. One wall was glass, looking out into a balcony with palm trees in the light mist. On the other wall were stenciled doors, like offices, park warden, guest services, general manager. Halfway down the corridor, they came to a glass partition marked with another sign, "Biohazard. Caution, biological hazard. This laboratory conforms to USG P4EK3 genetic protocols." Underneath were more signs. "Caution, teratogenetic substances. Pregnant women avoid exposure to this area. Danger, radioactive isotopes in use. Carcinogenic potential." Tim grew more excited all the time. Teratogenetic substances. Things that made monsters. It gave him a thrill, and he was disappointed to hear Ed Regis say, "Never mind the signs, they're just up for legal reasons. I can assure you everything is perfectly safe." He led them through a door. There was a guard on the other side. Ed Regis turned to the group. "You may have noticed that we have a minimum of personnel on the island. We can run this resort with a total of 20 people, of course, but we'll have more than when we have guests here. But at the moment, there's only 20. Here's our control room. The entire park is controlled from here." They paused before windows and peered into a darkened room that looked like a small version of mission control. There was a vertical glass see-through map of the park, and facing it a bank of glowing computer consoles. Some of the screens displayed data that most of them showed video images from around the park. There were just 2 people inside, standing and talking. "The man on the left is our chief engineer, John Arnold." Regis pointed to a thin man in a button-down short-sleeved shirt and tie, smoking a cigarette. "And next to him is our park warden, Mr. Robert Muldoon, the famous white hunter from Nairobi." Muldoon was a burly man in khaki, sunglasses dangling from his shirt pocket. He glanced out at the group, gave a brief nod, and turned back to the computer screens. "I'm sure you want to see this room," Ed Regis said. "But first, let's see how we obtained dinosaur DNA." The sign on the door said extractions, and like all of the doors in the laboratory building, it opened with the security card. Ed Regis slipped the card in the slot. The light blinked and the door opened. Inside, Tim saw a small room bathed in green light. 4 technicians in lab coats were peering into double-barreled stereo microscopes, or looking at images of high-resolution video screens. The room was filled with yellow stones. The stones were in glass shelves, in cardboard boxes, in large pull-out trays. Each stone was tagged and numbered in black ink. Regis introduced Henry Wu, a slender man in his 30s. Dr. Wu is our chief geneticist. I'll let him explain what we do here. Henry Wu smiled. At least I'll try, he said. Genetics is a bit complicated, but you're probably wondering where our dinosaur DNA comes from. It crossed my mind, Grant said. As a matter of fact, Wu said, there are 2 possible sources. Using the Loy antibody extraction technique, we can sometimes get DNA directly from dinosaur bones. What kind of yield? Grant asked. Well, most soluble proteins is leached out during fossilization, but 20% of the proteins are still recoverable by grinding them bones and using Loy's procedure. Dr. Loy himself had used it to obtain proteins from extinct Australian marsupials, as well as blood cells from ancient human remains. It's so refined it can work with a mere 50 nanograms of material. That's a 50 billionth of a gram. And you've adapted this technique here? Grant asked. Only as a backup, Wu said. As you can imagine, a 20% yield is insufficient for our work. We need the entire dinosaur DNA strand in order to clone, and we get it here. He held up one of the yellow stones. From amber, the fossilized resin of prehistoric tree sap. Grant looked at Ellie, then at Malcolm. That's really quite clever, Malcolm said, nodding. I still don't understand, Grant admitted. Tree sap, Boone explained, often flows over insects and traps them. The insects are then perfectly preserved within the fossil. One finds all kinds of insects in amber, including biting insects that have sucked blood from larger animals. Suck the blood, Grant repeated. His mouth fell open. You mean suck the blood of dinosaurs? Hopefully, yes. And then the insects are preserved in amber, Grant shook his head. I'll be damned, that just might work. I assure you, it does work, Wu said. He moved on to one of the microscopes, where a technician there positioned a piece of amber containing a fly under the microscope. On the video monitor, they watched as he inserted a long needle through the amber into the thorax of the prehistoric fly. If this insect has any foreign blood cells, we may be able to extract them and obtain paleo-DNA, the DNA of an extinct creature. We won't know for sure, of course, until we extract whatever is in there, replicate it, and test it. That is what we have been doing for 5 years now. It's would have been a long, slow process, but it paid off. Actually, dinosaur DNA is somewhat easier to extract by this process than mammalian DNA. The reason is that mammalian red cells have no nuclei, and thus no DNA in the red cells. To clone a mammal, you must find a white cell, which is much rarer in red cells, but dinosaurs had nucleated red cells, as do modern birds. It's one of the many indications we have dinosaurs aren't really reptiles at all. That they're just big, leathery birds. Tim saw that Dr. Grant still looked skeptical, and Dennis Nedry, the messy fat man, appeared completely uninterested, as if he knew it all already. Nedry kept looking impatient toward the next room. I see Mr. Nedry has spotted the next phases of our work, Wu said. How we identify the DNA we extracted. For that, we use powerful computers. They went through sliding doors into a chilled room. There was a loud humming sound. 2 6-foot-tall round towers stood in the center of the room, and along the walls were rows of waist-high stainless steel boxes. This is our high-tech laundromat, Dr. Wu said. The boxes along the walls are all Hamachi Hood automated gene sequencers. They're being run at very high speed by the Cray XMP supercomputers, which are the towers in the center of the room. In essence, you are standing in the middle of an incredibly powerful genetics factory. There were several monitors, all running so fast it was hard to see what they were showing. We pushed a button and slowed one image. Here is the same section of DNA with the points of the restriction enzymes located. As you can see in the line 1201, 2 enzymes will cut on either side of the damaged point. Ordinarily, we let the computers decide which to use, but we also need to know what base pairs we should insert to repair the injury. For that, we have to align various cut fragments like so. Now, we are finding a fragment of DNA that overlaps the injury area, and will tell us what is missing. And you can see we can find it, and go ahead and make the repair. The dark bars you see are restriction fragments, small section of dinosaur DNA, broken by enzymes and then analyzed. The computer is now recombining them by searching for overlapping sections of code. It's a little bit like putting a puzzle together. The computer could do it very rapidly. And here is the revised DNA strand, repaired by the computer. The operation you've witnessed would have taken months in a conventional lab, but we can do it in seconds. Then are you working with the entire DNA strand? Grant asked. Oh no, Wu said. That's impossible. We've come a long way from the 60s, when it took a whole laboratory 4 years to decode a screen like this. Now the computers can do it in a couple hours, but even so, the DNA molecule is too big. We look at only sections of the strand that differ from animal to animal, or from contemporary DNA. Only a few percent of the nucleotides differ from the one species to the next. That's what we analyze, and it's still a big job. Dennis Nedry yawned. He'd long ago concluded that InGen must be doing something like this. A couple of years earlier, when InGen had hired Nedry to design the part control systems, one of the initial design parameters called for the data records to be 3 by 10 to the 9th power fields. Nedry just assumed that was a mistake, and had called Palo Alto to verify it, but they had told him the spec was correct. 3 billion fields. Nedry had worked on a lot of large systems. He had made a name for himself setting up worldwide telephone communications for multinational corporations. Often those systems had millions of records. He was used to that, but InGen wanted something so much larger. Puzzled, Nedry had gone to see Barney Fellows over at Symbolics near MIT campus in Cambridge. What kind of database has 3 billion records, Barney? A mistake, Barney said, laughing. He put an extra 0 or 2. It's not a mistake, I checked. It's what they want. But that's crazy, Barney said. It's not workable, even if you had the fastest processors and blinding fast algorithms. A search could still take days, maybe weeks. Yeah, Nedry said. I know. Fortunately, I'm not being asked to do algorithms. I'm just being asked to reserve storage and memory for the overall systems, but still. What could the database be for? Barney frowned. You operating under an ND? Yeah, Nedry said. Most of his jobs required non-disclosure agreements. Can you tell me anything? It's a biological firm. Bioengineering? Barney said. Oh, that's obvious. Which is? A DNA molecule. Oh, come on, Nedry said. Nobody could be analyzing a DNA molecule. He knew biologists were talking about Human Genome Project to analyze a complete human DNA strand, but that would take 10 years of coordinated effort, involving laboratories around the world. It was an enormous undertaking, as big as the Manhattan Project, which made the atomic bomb. This is a private company, Nedry said. With 3 billion records, Barney said. I don't know what else it could be. Maybe they're being optimistic designing their system. Very optimistic, Nedry said. Or maybe they're just analyzing DNA fragments, but they've got RAM and tons of algorithms. That made more sense. Certain database search techniques ate a lot of memory. You know who did their algorithms? No, Nedry said. This company is very secretive. Well, my guess is they're doing something with DNA, Barney said. What's the system? Multi-XMP. Multi-XMP? You mean there's more than one Cray? Wow. Barney was frowning now, thinking that one over. Can you tell me anything else? Sorry, Nedry said. I can't. And he had gone back and designed the control systems. It had taken him and his programming team more than a year. It was especially difficult because the company would never tell him what the subsystems were for. The instructions were simply, design a module for record keeping, or design a module for visual display. They gave him design parameters, but no details about use. He'd been working in the dark, and now that the system was up and running, he wasn't surprised to learn that there were bugs. What did they expect? And they'd ordered him down here in a panic, all hot and bothered about his bugs. It was annoying, Nedry thought. Nedry turned back to the group as Grant asked, "And once the computer has analyzed the DNA, how do you know what animal it encodes?" "We have two procedures," Wu said. "First is phylogenetic mapping. DNA evolves over time, like everything else in an organism, hands or feet or any other physical attribute. So we can take an unknown piece of DNA and determine roughly by computer where it fits in the evolutionary sequence. It's time-consuming, but it can be done." "And the other way?" Wu shrugged. Just grow it and find out what it is," he said. "That's what we usually do. I'll show you how that's accomplished." Tim felt a growing impatience as the tour continued. He liked technical things, but even so, he was losing interest. They came to the next door, which was marked Fertilization. Dr. Wu unlocked the door with a security card, and they went inside. Tim saw still another room with technicians working at microscopes. In the back was a section entirely lit by blue ultraviolet light. Dr. Wu explained that their DNA work required the interruption of cellular mitosis at precise instants, and therefore they kept some of the most virulent poisons in the world. "Helotoxins, flavonoids, beta-alkaloids," he said, pointing to a series of syringes set out under the UV light. "Kill any living animal within a second or two." Tim would have liked to know more about the poisons, but Dr. Wu droned on about using unfertilized crocodile ova and replacing the DNA. And then Professor Grant asked some complicated questions. To one side of the room were big tanks marked Liquid N2 and the DNA. And there were big walk-in freezers with shelves of frozen embryos, each stored in a tiny silver foil wrapper. Lex was bored, Nedry was yawning, and even Dr. Sattler was losing interest. Tim was tired of looking at these complicated laboratories. He wanted to see the dinosaurs. The next room was labeled Hatchery. "It's a little warm and damp in here," Dr. Wu said. "We keep it 99 degrees Fahrenheit with a relative humidity of 100%. We also run a higher O2 concentration. It's up to 33%. "Jurassic atmosphere," Gret said. "Yeah, at least we presume so. If any of you feel faint, just tell me." Dr. Wu inserted his security card into the slot, and the outer door hissed open. "Just a reminder, don't touch anything in this room. Some of the eggs are permeable to skin oils, and watch your heads. The sensors are always moving." He opened the inner door to the nursery, and they went inside. Tim faced a vast open room, bathed in deep infrared light. The eggs lay on the long tables, the pale outlines obscured by the hissing low mist that covered the tables. The eggs were all moving gently, rocking. Reptile eggs contain huge, large amounts of yolk, but no water at all. The embryos must extract water from the surrounding environment, hence the mist. Dr. Wu explained that each table contained 150 eggs, and represented a new batch of DNA extractions. The batches were identified by numbers at each table, Steg 458-2 or Trike 390-4. Waist deep in the mist, the workers in the nursery removed one egg to the next, plunging their hands into the mist, turning the eggs every hour, and checking the temperatures with thermal sensors. The room was monitored by overhead TV cameras and motion sensors. An overhead thermal sensor moved from one egg to the next, touching each with a flexible wand, beeping, then going on. "In this hatchery, we have produced more than a dozen crops of extractions, giving us a total of 238 live animals. Our survival rate is somewhere around 0.4%, and we naturally want to improve that. But by computer analysis, we're working with something like 500 variables, 120 environmental, another 200 inter-egg, and the rest of the genetic material itself. Our eggs were plastic. The embryos are mechanically inserted and then hatched here." "And how long to grow?" "Dinosaurs mature rapidly, attaining full size in 2 to 4 years, so we now have a number of adult specimens in the park." "What do the numbers mean?" "Those codes," Wu said, "identify the various batch extractions of DNA. The first 4 letters identify the animals being grown. Over there, that TRIC means Triceratops, and the STEG means Stegosaurus, and so on." "And this table here?" Grant said. The code said XXX0001/1. Beneath was scrawled, "Presumed Kolu." "Oh, that's a new batch of DNA," Wu said. "We don't know exactly what will grow out. The first time an extraction is done, we don't know for sure what the animal is. You can see it marks Presumed Kolu, so it's likely to be a Colosaurus, but a small herbivore, if I remember. It's hard for me to keep track of the names. There are something like 300 genera of dinosaurs known so far." 347, Tim said. Grant smiled, then said, Is anything hatching now? Not at the moment. The incubation period varies with each animal, but in general it runs about 2 months. We try to stagger hatchings to make less work for the nursery staff. You can imagine how it is when we have 150 animals born within a few days, though of course, most don't survive. Actually, these X's are due any day now. Any other questions? No? Then we'll go to the nursery, where the newborns are. It was a circular room, all white. There were some incubators of the kind used in hospital nurseries, but they were empty at the moment. Rags and toys were scattered across the floor. A young woman in a white coat was seated on the floor, her back to them. "What have you got here today, Kathy?" Dr. Wu asked. "Not much," she said. "Just a baby raptor." "Let's have a look." The woman got to her feet and stepped aside. Tim heard Nedry say, "Looks like a lizard." The animal on the floor was about 1.5 feet long, the size of a small monkey. It was dark yellow with brown stripes, like a tiger. It had a lizard's head and a long snout, but it stood upright on strong hind legs, balanced by a thick straight tail. Its smaller front legs waved in the air. It cocked its head to one side and appeared at the visitors staring down at it. "Velociraptor," Alengrad said in a low voice. "Velociraptor mongoliensis," Wu said, nodding. "A predator. This one's only 6 weeks old." I just excavated a raptor," Grant said as he bent down for a closer look. Immediately the little lizard sprang up, leaping over Grant's head into Tim's arms. "Hey!" "They can jump," Wu said. "The babies can jump. So can the adults, as a matter of fact." Tim caught the velociraptor and held it to him. The little animal didn't weigh very much. A pound or two. The skin was warm and completely dry. The little head was inches from Tim's face. Its dark, beady eyes stared at him. A small forked tongue flicked out. "Will he hurt me?" "No, she's friendly." "Are you sure about that?" asked Gennaro with a look of concern. "Oh, quite sure. At least until she grows a little older, but in any case, the babies don't have any teeth. Even egg teeth." "Egg teeth?" Nedry said. "Most dinosaurs are born with egg teeth, little horns at the tip of their nose, like rhino horns, to help them break out of the eggs, but raptors aren't. They poke a hole in the eggs with their pointed snouts, and then the nursery staff has to help them out." "You have to help them out?" Grant said, shaking his head. "What happens in the wild?" "In the wild?" "When they breed in the wild," Grant said. "When they make a nest." Oh, they can't do that," Wu said. "None of our animals are capable of breeding. That's why we have this nursery. It's the only way to replace stock in Jurassic Park." "Why can't the animals breed?" "Well, as you can imagine, it's important that they not be able to breed," Wu said. "And whenever we faced a critical matter such as this, we designed redundant systems. That is, we always arranged at least 2 control procedures. In this case, there are 2 independent reasons why the animals can't breed. First of all, they're sterile, because we irradiate them with X-rays." "And the second reason?" "All the animals in Jurassic Park are female," Wu said, with a pleased smile. Malcolm said, "I would like some clarification about this, because it seems to me that irradiation is fraught with uncertainty. The radiation dose may be wrong, or aimed at the wrong anatomical area of the animal." "All true," Wu said. "But we're quite confident we have destroyed gonadal tissue." "And as for them all being female," Malcolm said, "is that checked? Does anyone go and, lift up the dinosaur skirts to have a look? I mean, how does one determine the sex of a dinosaur anyway?" "Sex organs vary with the species. It's easy to tell on some, subtle on others, but to answer your question, the reason we know all the animals are female is that we literally make them that way. We control their chromosomes, and we control the intra-egg developmental environment. From a bioengineering standpoint, females are easiest to breed. You probably know that all vertebrate embryos are inherently female. And we all start life as females. It takes some kind of added effect, such as a hormone at the right moment during development to transform the growing embryo into a male, but left to its own devices, the embryo will naturally become female. So, our animals are all female. We tend to refer to some of them as male, such as the Tyrannosaurus rex. We call it him, but in fact they're all female, and believe me, they can't breed. That's some fucked up misgendering." The little velociraptor sniffed at Tim, and then rubbed her head against Tim's neck. Tim giggled. She wants you to feed her, Wu said. What does she eat? Mice, but she's just eaten, so won't feed her again for a while. The little raptor leaned back, stared at Tim, and wiggled her forearms again in the air. Tim saw the small claws on the 3 fingers of each hand. Then the raptor burrowed her head against his neck again. Grant came over and peered critically at the creature. He touched the tiny 3-clawed hand. He said to Tim, "Do you mind?" And Tim released the raptor into his hands. Grant flipped the animal onto its back, inspecting it, while the little lizard wiggled and squirmed. Then he lifted the animal high to look at its profile, and it screamed shrilly.
She doesn't like that, Regis said. Doesn't like to be held away from body contact.
The raptor was still screaming, but Grant paid no attention. Now he was squeezing the tail, feeling the bones.
Regis said, Dr. Grant, if you please.
I'm not hurting her.
Dr. Grant, these creatures are not from our world. They come from a time when there were no human beings around to prod and poke them.
I'm not prodding and...
Dr. Grant, put her down, Ed Regis said. But now.
Regis was starting to get annoyed. Grant handed the animal back to Tim. It stopped squealing. Tim could feel its little heart beating rapidly against his chest.
I'm sorry, Dr. Grant, Regis said, but these animals are delicate in infancy. We've lost several from postnatal stress syndrome, which we believe is cordially medicated, but sometimes they'll die within 5 minutes.
Tim petted the little raptor. It's okay, kid, he said. Everything's fine now. The heart was still beating rapidly.
We feel it's important that the animals were treated in the most humane manner, Regis said. I promise you that you will have every opportunity to examine them later.
But Grant couldn't stay away. He again moved toward the animal in Tim's arms, peering at it. The little velociraptor opened her jaws and hissed at Grant, in a posture of its sudden, intense fury. Fascinating, Grant said. Can I stay and play with her? Tim said.
Not right now, Ed Regis said, glancing at his watch. It's 3 o'clock and it's a good time for the tour of the park itself. You can see all the dinosaurs in the habitats we have designed for them.
Tim released the velociraptor, which scampered across the room, grabbed the cloth rag, put it in her mouth, and tugged at the end with her tiny claws. Control. Walking back toward the control room, Malcolm said, I have one more question, Dr. Wu. How many different species have you made so far? I'm not exactly sure, Wu said. I believe the number at the moment is 15? 15 species. Do you know, Ed?
Yes, it's 15,
Ed Regis said, nodding. You don't know for sure? Malcolm said, affecting astonishment. Wu smiled. I stopped counting, he said. After the first dozen, you have to realize that sometimes we think we have an animal correctly made from the standpoint of DNA, which is our basic work, and the animal grows for 6 months, and then something untoward happens, and we realize there's some error. A releaser gene isn't operating, a hormone not being released, or some other problem in the developmental sequence, so we have to go back to the drawing board with the animal, so to speak. So, at one time I thought I had more than 20 species, but now, only 15. And is one of the 15 species a... Malcolm turned to Grant. What was the name? Proconsognthus, Grant said. You've made some Proconsognathuses, or whatever they're called? Malcolm asked. Oh, yes, Wu said immediately. Copies are very distinctive animals, and we have made an unusually large number of them. Why is that? Well, we want Jurassic Park to be as real an environment as possible, as authentic as possible, and the Proconsognathuses are actual scavengers from the Jurassic period, rather like jackals, so we wanted to have the copies around to clean up. You mean to dispose of carcasses? Yes, if there are any, but with only 230-odd animals in our total population, we don't really have many carcasses, Wu said. That wasn't the primary objective. Actually, we wanted the copies for another kind of waste management entirely. Which was? Well, Wu said, we have some very big herbivores on this island, and we have specifically tried not to breed the biggest sauropods, but even so, we've got several animals in excess of 30 tons walking around out there, and many others in the 5 to 10 ton area. That gives us 2 problems. One is feeding them, and the fact that we must import food to the island every 2 weeks. There's no way an island this small can support these animals for any time. But the other problem is waste. I don't know if you've ever seen an elephant droppings, Wu said, but They are substantial. Each spore is roughly the size of a soccer ball. Imagine the droppings of a brontosaur 10 times as large. Now imagine the droppings of a herd of such animals as we keep here. And the largest animals do not digest their food terribly well, so that they excrete a great deal. And in the 60 million years since dinosaurs disappeared, apparently the bacteria that specialize in breaking down their feces disappeared too. At least the sauropod feces don't decompose readily. That's a problem, Malcolm said. I assure you it is, Wu said, not smiling. We had a hell of a time trying to solve it. You probably know that in Africa there is a specific insect, the dung beetle, which eats elephant feces. Many other large species have associated creatures that have evolved to eat their excrement. Well, it turns out that compies will eat the feces of large herbivores and redigest it. And the droppings of compies are readily broken down by contemporary bacteria, so given enough compies, our problem was solved. How many compies did you make? I've forgotten exactly, but I think the target population was 50 animals? And we attained that, or very nearly so, in 3 batches. We did a batch every 6 months until we had the number. 50 animals, Malcolm said, is a lot to keep track of. The control room is built to do exactly that. They'll show you how it's done. I'm sure, Malcolm said. But if one of these compies were to escape from the island to get away, they can't get away. I know that, but just supposing one did. You mean like the animal that was found on the beach, Wu said, raising his eyebrows? The one that bit the American girl? Yes, for example. I don't know what the explanation for that animal is, Wu said, but I know it can't possibly be one of ours, for 2 reasons. First, the control procedures. Our animals are counted by computer every few minutes. If one were missing, we'd know at once. And the second reason? The mainland is more than 100 miles away, and it takes almost a day to get there by boat. And in the outside world, our animals will die within 12 hours, Wu said. How do you know? Because I've made sure that's precisely what will occur, Wu said, finally showing a trace of irritation. Look, we're not fools. We understand that these prehistoric animals, they are part of a vanished ecology, a complex web of life that became extinct millions of years ago. They might have no predators in contemporary world, no checks on their growth. We don't want them to survive in the wild. So I made them lysine dependent. I inserted a gene that makes them a single faulty enzyme in protein metabolism. As a result, the animal cannot manufacture the amino acid lysine. They must ingest it from the outside. Unless they get a rich dietary source of exogenous lysine supplied by us in tablet form, they'll go into a coma within 12 hours and expire. These animals are genetically engineered to be unable to survive in the real world. They can only live here in Jurassic Park. They are not free at all. They are essentially our prisoners. Here's the control room, Ed Regis said. Now that you know how the animals are made, you'll want to see the control room for the park itself before we get out onto the... He stopped. Through the thick glass window, the room was dark. The monitors were off except for 3 that displayed spinning numbers and the image of a large boat. What's going on? Ed Regis said. Oh, hell, they're docking. Docking? Every 2 weeks, a supply boat comes over the mainland. One of the things the island doesn't have is a good harbor, or even a good dock. It's a little hairy to get the ship in when the seas are rough. Could be a few minutes. He rapped on the window, but the men inside paid no attention. I guess we have to wait then. Ellie turned to Dr. Wu. You mentioned before that sometimes you make an animal that seems to be fine, but as it grows, it shows itself to be flawed. Yes, Wu said. I don't think there's any way around that. We can duplicate the DNA, but there's a lot of timing and development, and we don't know if everything is working unless we actually see an animal develop correctly. Grant said, how do you know if it's developing correctly? No one has ever seen these animals before. Wu smiled. I've often thought about that. I suppose it's a bit of a paradox. Eventually I hope paleontologists such as yourself will compare our animals with the fossil record to verify the developmental sequence. Ellie said, but the animal we just saw, the velociraptor, you said it was a Mongoliensis? From the location of the amber, Wu said it's from China. Interesting, Grant said. I was just digging up an infant Anthropus, and there's a fully grown raptors here. Yes, Ed Regis said without hesitation. 8 adult females. The females are real hunters. They're pack hunters, you know. Will we see them on our tour? No, Wu said, looking suddenly uncomfortable, and there was an awkward pause. Wu looked at Regis.
Not for a while, Regis said cheerfully. The velociraptors haven't been integrated into the park setting just yet. We keep them in a holding pen.
Can I see them there? Grant said.
Why, yes, of course. In fact, while we're waiting, he glanced at his watch, you might want to go and have a look at them.
I certainly would, Grant said. Absolutely, Ellie said. I want to go too, Tim said eagerly.
Just go around the back of this building, past the support facility, and you'll see the pen. But don't get too close to the fence. Do you want to go too? He said to the girl.
No, Lex said. She looked appraisingly at Regis. You want to play a little pickle? Throw a few?
Well, sure, Regis said. Why don't you and I go downstairs and we'll do that while we wait for the control room to open.
Grant walked with Ellie and Malcolm around the back of the main building, with the kid tagging along. Grant liked kids. It was impossible not to like any group so openly enthusiastic about dinosaurs. Grant used to watch kids in museums as they stared open-mouthed at the big skeletons rising above them. He wondered what their fascination really represented. He finally decided that children liked dinosaurs because these giant creatures personified the uncontrollable force of looming authority. They were symbolic parents. Fascinating and frightening, like parents, and kids loved them, as they loved their parents. Grant also suspected that's why even young children learned the names of dinosaurs. It never failed to amaze him when a 3-year-old shrieked, "Stegosaurus!" Saying these complicated names was a way of exerting power over the giants, a way of being in control. What do you know about Velociraptor? Grant asked Tim. He was just making conversation. Small carnivore that hunted in packs like Deinonychus, Tim said. That's right, Grant said. Although Deinonychus is now considered one of the velociraptors, and the evidence for pack hunting is all circumstantial. It derives in part from the appearance of the animals, which are quick and strong, but small for dinosaurs, just 150 to 300 pounds each. We assume that they hunted in groups, if they're to bring down larger prey, and there are some fossil finds in which a single large prey animal is associated with several raptor skeletons, suggesting they hunted in packs, and of course, raptors were large-brained, more intelligent than most dinosaurs. How intelligent is that? Malcolm said. Depends on who you talk to, Grant said. Just as paleontologists have come around to the idea that dinosaurs are probably warm-blooded, a lot of us are starting to think some of them might have been quite intelligent too, but nobody knows for sure. They left the visitor area behind, and soon they heard the loud hum of generators, smelled the faint odor of gasoline. They passed a grove of palm trees and saw a large, low, concrete shed with a steel roof. The noise seemed to come from there. They looked in the shed. Must be a generator, Ellie said. It's big, Grant said, peering inside. The power plant actually extended 2 stories below ground level, a vast complex of winding turbines and piping that just ran down in the earth, lit by harsh electric bulbs. They can't need all this just for a resort, Malcolm said. They're generating enough power here for a small city. Maybe for the computers? Maybe. Grant heard bleating, and walked north a few yards. He came to an animal enclosure with goats. By a quick count, he estimated there were 50 or 60 goats. What's that for? Ellie asked. Beats me. Probably they feed them to the dinosaurs, Malcolm said. The group walked on, following a dirt path through the dense bamboo grove. At the far side, they came to a double-layer chain-link fence 12 feet high, with spirals of barbed wire at the top. There was an electric hum along the outer fence. Beyond the fences, Grant saw dense clusters of large ferns 5 feet high. He heard a snorting sound, a kind of snuffling, then a sort of crunching footsteps coming closer. Then a long silence. I don't see anything, Tim whispered finally. Shh! Grant waited. Several seconds passed. Flies buzzed in the air. He still saw nothing. Ellie tapped him on the shoulder and pointed. Amid the ferns, Grant saw the head of an animal. It was motionless, partially hidden in the fronds, and 2 large, dark eyes watching them coldly. The head was 2 feet long. From a pointed snout, a long row of teeth ran back to the hole of the auditory meatus, which served as an ear. The head reminded him of a large lizard, or perhaps a crocodile. The eyes did not blink, and the animal did not move. The skin was leathery with a pebble texture, and basically the same coloration with the infant's, yellow-brown with darker reddish markings like the stripes of a tiger. As Grant watched, A single forelimb reached up very slowly to the part of the ferns beside the animal's face. The limb, Grant saw, was strongly muscled. The hand had 3 grasping fingers, each ending in curved claws. The hand gently, slowly pushed aside the ferns. Grant felt a chill and thought, "He's hunting us." For a mammal like man, there was something indescribably alien about the way reptiles hunted their prey. No wonder men hated reptiles. The stillness, the coldness, the pace was all wrong. To be among alligators or other large reptiles was to be reminded of a different kind of life. A different kind of world, now vanished from the earth. Of course, this animal didn't realize that he had been spotted, The attack came suddenly from the left and right. Charging raptors covered the 10 yards to the fence with shocking speed. Grant had blurred impression of powerful 6-foot-tall bodies, stiff, balancing tails, limbs with curving claws, open jaws, and rows of jagged teeth. The animals snarled as they came forward, and they leapt bodily into the air, raising their hind legs with big dagger claws. Then they struck the fence in front of them, throwing off twin bursts of hot sparks. The velociraptors fell backward to the ground, hissing. The visitors all moved forward, fascinated. Only then did the third animal attack, leaping up to strike the fence at chest level. Tim screamed in fright as the sparks exploded around him. The creature snarled, a low reptilian hissing sound, and leaped back among the ferns. Then they were gone, leaving behind a faint odor of decay and hanging acrid smoke. "Holy shit!" Tim said. "It was so fast," Ellie said. "Pack hunters," Grant said, shaking his head. "Pack hunters for whom ambush is an instinct. Fascinating." "I wouldn't call them tremendously intelligent," Malcolm said. On the other side of the fence they heard snorting in the palm trees. Several heads poked slowly out of the foliage. Grant counted 3, 4, 5. The animals watched them, staring coldly. A black man in coveralls came running up to them. "Are you all right?" "We're okay," Grant said. "The alarms were set off." A man looked at the fence, dented and charred. "They attacked you?" "3 of them, yes." The black man nodded. "They do that all the time. Hit the fence, take a shock. They never seem to mind." "Not too smart, are they?" Malcolm said. The black man paused and squinted at Malcolm in the afternoon light. "Be glad for that fence, senor," he said, and turned away. From the beginning to end, the entire attack could not have been more than 6 seconds. Grant was still trying to organize his impressions. The speed was astonishing. The animals were so fast and had hardly seen them move. Walking back, Malcolm said, "They are remarkably fast." "Yes," Grant said. "Much faster than any living reptile. The bull alligator can move quickly, but only on a short distance. 5 or 6 feet. Big lizards like 5-foot Komodo dragons of Indonesia have been cloaked at 30 miles an hour. Fast enough to run down a man. And they kill men all the time. But I'd guess the animal behind the fence was more than twice as fast." "Cheetah speed," Malcolm said. 60, 70 miles an hour?" "Exactly." "But they seem to dart forward," Malcolm said, "rather like birds." "Yes. In the contemporary world, only very small mammals like cobra-fighting mongoose had such quick responses. Small mammals and, of course, birds. The snake-hunting secretary bird of Africa, or the cassowary. In fact, the velociraptor conveyed precisely the same impression of deadly swift menace. Grant had seen in the cassowary the clawed ostrich-like foot of New Guinea. "So these velociraptors look like reptiles, with the skin and general appearance of reptiles, but they move like birds, with the speed and predatory intelligence of birds. Is that about it?" Malcolm said. "Yes," Grant said. "I'd say they display a mixture of traits." "Does that surprise you?" "Not really," Grant said. "It's actually rather close to what paleontologists believed a long time ago." The first giant bones were found in the 1820s and 1830s. Scientists felt obliged to explain the bones as belonging to some oversized variant of a modern species. This was because it was believed that no species could ever become extinct, since God would not allow one of his creations to die. Eventually, it became clear that this conception of God was mistaken, and the bones belonged to extinct animals. But what kind of animals? In 1842, Richard Owen, the leading British anatomist of the day, called them dinosauria, meaning terrible lizards. Owen recognized that dinosaurs seemed to combine traits of lizards, crocodiles, and birds. In particular, dinosaur hips were bird-like.
not lizard-like, and unlike lizards, many dinosaurs seem to stand upright. Owen imagined dinosaurs to be quick-moving, active creatures, and his view was accepted for the next 40 years. But when truly gigantic finds were unearthed, animals that had weighed 100 tons in life, scientists began to envision that the dinosaurs are stupid, slow-moving giants destined for extinction. The image of the sluggish reptile gradually predominated over the image of the quick-moving bird. In recent years, scientists like Grant had begun to swing back toward the idea of a more active dinosaurs. Grant's colleagues saw him as radical in his conception of dinosaur behavior, but now he had to admit his own conception falling short of the reality of these large, incredibly swift hunters.
Actually, what I was driving at, Malcolm said, was this. Is it a persuasive animal to you? Is it, in fact, a dinosaur?
I'd say so, yes.
And the coordinated attack behavior?
To be expected, Grant said. According to the fossil records, packs of velociraptors were capable of bringing down animals that weighed 1,000 pounds, like Tyrannosaurus, which could run as fast as a horse. Coordination would be required.
How do they do that without language?
Oh, language isn't necessary for coordinated hunting, Ellie said. Chimpanzees do it all the time. A group of chimps will stalk a monkey and kill it. All communication is by eyes.
And were the dinosaurs in fact attacking us?
Yes.
They could kill us and eat us if they could, Malcolm said.
Think so.
The reason I ask, Malcolm said, is that I'm told large predators such as lions and tigers are not born man-eaters. Is that true? These animals must learn somewhere along the way that human beings are easy to kill? Only afterwards do they become man-eaters?
Yes, I believe that's true, Grant said.
Well, these dinosaurs must be even more reluctant than lions and tigers. After all, they come from a time before human beings or even larger mammals even existed at all. God knows what they think, what they see us. So I wonder, have they learned somewhere along that line that humans are easy to kill?
The group fell silent as they walked.
In any case, Malcolm said, I shall be extremely interested to see the control room now.
Version 4.4. Was there any problem with the group? Hammond asked. No, Henry said. There was no problem at all. They accepted our explanation? Why shouldn't they? Wu said. It's all quite straightforward in the broad strokes. It's only the details that get sticky. And I wanted to talk about the details with you today. You can think of it as a matter of aesthetics. John Hammond wrinkled his nose as if he smelled something disagreeable. Aesthetics? He repeated. They were standing in the living room of Hammond's elegant bungalow, set back among palm trees in the northern sector of the park. The living room was airy and comfortable, fitted with a half-dozen video monitors showing the animals in the park. The file Wu had brought stamped Animal Development version 4.4 lay on the coffee table. Hammond was looking at him in that patient, paternal way. Wu, 33 years old, was acutely aware that he had worked for Hammond all his professional life. Hammond had hired him right out of graduate school. Of course, there are practical consequences as well, Wu said. I really think you should reconsider my recommendations for Phase 2. We should go to version 4.4. You want to replace all the current stock of animals? Hammond said. Yes, I do. Why? What's wrong with them? Nothing, Wu said, except that they're real dinosaurs. That's what I asked for, Henry, Hammond said, smiling, and that's what you gave me. I know, Wu said, but you see... He paused. How could he explain this to Hammond? Hammond hardly ever visited the island, and it was a peculiar situation that Wu was trying to convey. Right now, as we stand here, almost no one in the world has ever actually seen an actual dinosaur. Nobody knows what they really like. Yes? The dinosaurs we have now are real, Wu said, pointing to the screens around the room. But in certain ways they are unsatisfactory, unconvincing. I can make them better. Better in what way? For one thing, they move too fast, Wu said. People aren't accustomed to seeing large animals that are so quick. I'm afraid visitors will think the dinosaur looks speeded up, like film running too fast. But Henry, these are real dinosaurs. You said so yourself. I know, Wu said, but we could easily breed them slower, more domesticated dinosaurs. Domesticated dinosaurs, Hammond snorted. Nobody wants domesticated dinosaurs, Henry. They want the real thing. But that's my point, Wu said. I don't think they do. They want to see their expectation, which is quite different. Hammond was frowning. You said yourself, John, this park is entertainment, Wu said. And entertainment has nothing to do with reality. Entertainment is antithetical to reality. Hammond sighed. Now, Henry, are we going to have another one of those abstract discussions? You know I like to keep it simple. The dinosaurs we have are real and... Well, not exactly, Wu said. He paced the living room, pointing to the monitors. I don't think we should kid ourselves. We haven't recreated the past here. The past is gone. It can never be recreated. What we've done is reconstruct the past, or at least a version of the past, and I'm saying we can make a better version. Better than real? Why not? We said. After all, these animals are already modified. We've inserted genes to make them patentable, to make them lysine dependent, and we've done everything we can to promote growth and accelerate development into adulthood. Hammond shrugged. That was inevitable. We didn't want to wait. We had investors to consider. Of course. But I'm saying, why stop there? Why not push ahead to make exactly the kind of dinosaur that we'd like to see? One that is more acceptable to visitors and one that is easier for us to handle. A slower, more docile version for our park. Hammond frowned. But then the dinosaurs won't be real. But they're not real now, Wu said. That's what I'm trying to tell you. There isn't any reality here. He shrugged helplessly. You could see he wasn't getting through. Hammond had never been interested in technical details, and the essence of the argument was technical, so how could he explain to Hammond about the reality of DNA dropouts, the patches, the gaps in the sequence that Wu had been obligated to fill in, making the best guesses he could, but still making guesses? The DNA of dinosaurs was like an old photographs that had been retouched, basically the same as the original, but in some places repaired and clarified, and as a result... Now, Henry, Hammond said, putting his arm around Wu's shoulder, if you don't mind me saying so, I think you're getting cold feet. You've been working very hard for a long time, and you've done a hell of a job, And it's finally time to reveal to some people what you've done. It's natural to be a little nervous, to have some doubts, but I'm convinced, Henry, that the world will be entirely satisfied. Entirely satisfied. As he spoke, Hammond steered him toward the door. But John, Wu said, remember back in '87 when we started to build the containment devices? We didn't have any full-grown adults yet. So we had to predict what we'd need. We ordered big taser shockers, cars with cattle prods mounted on them, guns that blow electrical nets, all built specifically to our specifications. We've got a whole array of devices now, and they're all too slow. We've got to make adjustments. You know that Muldoon wants military equipment. Law missiles, laser-guided devices. Let's leave Muldoon out of this, Hammond said. I'm not worried. It's just a zoo, Henry. The phone rang, and Hammond went to answer it. Wu tried to think of another way to press his case, but the fact was that, after 5 long years, Jurassic Park was nearing completion, and John Hammond wasn't listening to him anymore. There had been a time when Hammond listened to Wu very attentively, especially when he had first recruited him back in the days when Henry Wu was a 28-year-old graduate student getting his doctorate at Stanford in Norman Atherton's lab. Atherton's death had thrown the lab into confusion as well as mourning. No one knew what would happen to the funding or the doctoral programs. There was a lot of uncertainty. People worried about their careers. 2 weeks after the funeral, John Hammond came to see Wu. Everyone in the lab knew that Atherton had some association with Hammond, although the details were never clear. But Hammond had approached Wu with the directness Wu never forgot. Norman always said you were the best geneticist in his lab, he said. What are your plans now? I don't know. Research? You want a university appointment? Yeah. That's a mistake, Hammond said briskly. At least if you respect your talent. Wu blinked. Why? Because, let's face facts, Hammond said. Universities are no longer intellectual centers of the country. The very idea is preposterous. Universities are now the backwater. Don't look so surprised. I'm not saying anything you don't know. Since World War II, all the really important discoveries have come out of private laboratories. The laser, the transistor, the polio vaccine, The microchip, the hologram, the personal computer, magnetic resonance image, CAT scans, the list goes on and on. Universities simply aren't where it's happening anymore. And they haven't for 40 years. If you want to do something important in computers or genetics, you don't do it in university. Dear me, no. Wu found he was speechless. Good heavens, Hammond said. What must you go through to start a new project? How many grant applications? How many forms? How many approvals? The steering committee, the department chairman, university resources committee. How do you get more workspace if you need it? More assistants if you need them. How long does it take? A brilliant man can't squander precious time with forms and committees. Life is too short and DNA too long. You want to make your mark? You want to get something done? Stay out of universities. In those days, Wu desperately wanted to make his mark. John Hammond had his full attention. I'm talking about work, Hammond continued. Real accomplishment. What does a scientist need to work? He needs time. He needs money. And I'm talking about giving you a 5-year commitment, a $10 million a year in funding, $50 million, and no one tells you how to spend it. You decide. Everyone else just gets out of your way. It sounded too good to be true. Wu was silent for a long time. Finally, he said, in return for what? For taking a crack at the impossible, Hammond said. For trying something that probably can't be done. What does it involve? I can't give you details, but the general area involves cloning reptiles. I don't think that's impossible. Who said reptiles are easier than in mammals? Cloning's probably only 10, 15 years off, assuming some fundamental advances. I've got 5 years, Hammond said, and a lot of money for somebody who wants to take a crack at it now. Is my work publishable? Eventually. Not immediately? No. But eventually publishable, Wu asked, sticking on this point. Hammond laughed. Don't worry. If you succeed, the whole world will know about what you've done. I promise you. Now it seemed the whole world would indeed know, Wu thought. After 5 years of extraordinary effort, they were just a year away from opening the park to the public. Of course, those years hadn't gone exactly as Hammond had promised. Wu had some people telling him what to do, and many times fearsome pressures were placed on him. And the work itself had shifted. It wasn't even reptilian cloning once they began to understand that dinosaurs were so similar to birds. It was avian cloning, a very different proposition. Much more difficult, and for the last 2 years, Wu had been primarily administrator, supervising teams of researchers and banks of computer-operated gene sequencers. Administration wasn't the kind of work he relished. It wasn't what he bargained for. Still, he succeeded. He had done what nobody really believed can be done, at least in so short a time. And Hen Wu thought that he should have some rights. Some say in what happened by virtue of his expertise and his efforts. Instead, he found his influence waning with each passing day. The dinosaurs existed. The procedures for obtaining them were worked out to the point of being routine. The technologies were mature, and John Hammond didn't need Henry Wu anymore. That should be fine, Hammond said, speaking into the phone. He listened for a while, then smiled at Wu. Fine, yes, fine. He hung up. Where were we, Henry? We were talking about Phase 2, Wu said. Oh, yes. We've gone over some of this before, Henry. I know, but you don't realize... Excuse me, Henry, Hammond said with an edge of impatience to his voice. I do realize. And I must tell you frankly, Henry, I see no reason to improve on reality. Every change we've made in the genome has been forced on us by law or necessity, but we make other changes in the future. To resist disease or for other reasons, but I don't think we should improve upon reality just because we think it's better that way. We have real dinosaurs out there now. That's what people want to see, and that's what they should see. That's our obligation, Henry. That's honest, Henry. And smiling, Hammond opened the door for him to leave.
Control. Grant looked at all the computer monitors in the darkened control room, feeling irritable. Grant didn't like computers. He knew that this made him old-fashioned, dated as a researcher, but he didn't care. Some of the kids who worked for him had a real feeling for computers, an intuition. Grant never felt that. He found computers to be alien, mystifying machines. Even the fundamental distinction between an operating system and an application left him confused and disheartened, literally lost in a foreign geography he didn't begin to comprehend. But he noticed that Gennaro was perfectly comfortable, and Malcolm seemed to be in his element, making sniffing sounds like a bloodhound on a trail. "You want to know about control mechanisms?" John Arnold said, turning in his chair in the control room. The head engineer was a thin, tense, chain-smoking man of 45. He squinted at the others in the room. "We have unbelievable control mechanisms," Arnold said, and lit another cigarette. "For example?" Gennaro said. "For example, animal tracking." Arnold pressed the button on his console, and the vertical glass map lit up with a pattern of jagged blue lines. "That's our juvenile T-Rex. The little Rex, all his movements within the park over the last 24 hours. Arnold pressed the button again. Previous 24. And again, previous 24. The lines on the map became densely overlaid. A child's scribble. But the scribble was localized in a single area near the southeast side of the lagoon. "You got a sense of his home range over time," Arnold said. "He's young, so he stays close to the water. And he stays away from the big adult Rex. You put up the big Rex and the little Rex and you'll see their paths never cross." "Where's the big Rex now?" Gennaro asked. Arnold pushed another button. The map cleared, and a single glowing spot with the code number appeared in the fields northwest of the lagoon. "He's right there." "And the little Rex?" "Hell, I'll show you every animal in the park," Arnold said. The map began to light up like a Christmas tree, dozens of spots of light, each tagged with the code number. "That's 238 animals as of this minute." "How accurate?" Within 5 feet," Arnold puffed on the cigarette. "Let's put it this way. You drive out in a vehicle and you'll find the animals right there, exactly as you've shown on the map." "How often is this updated?" Every 30 seconds. "Pretty impressive," Gennaro said. "How's it done?" "We have motion sensors all over the park," Arnold said. "Most of them are hardwired, some radio telemetered. Of course, motion sensors won't usually tell you the species, but we get image recognition direct off the video. Even when we're not watching the video monitors, the computer is, and checking where everybody is." "Does the computer ever make a mistake?" Only with the babies. It mixes those up sometimes because they're such small images, but we don't sweat that. The babies almost always stay close to herds of adults. Also, you have the category tally." "What's that?" Once every 15 minutes, the computer tallies the animals in all categories," Arnold said. "Like this. Total animals, 238. Tyrannosaurs, expected 2, found 2, version 4.1. Myosaurs, expected 21, found 21, version 3.3. Stegosaurs, expected 4, found 4, version 3.9. Triceratops, expected 8, found 8, version 3.1. Proconsopanthids, expected 49, found 49, version 3.9. Othnielia, expected 16, found 16, version 3.1. Velociraptors, expected 8, found 8, version 3.0. Apatosaurs, expected 17, found 17, version 3.1. Hadrosaurs, expected 11, found 11, version 3.1. Dilophosaurs, expected 7, found 7, version 4.3. Pterosaurs, expected 6, found 6, version 4.3. Pterosaurs, expected 6, found 6, version 4.3. Hypsilophodontids, expected 33, found 33, version 2.9. Euplacephalids, expected 16, found 16, version 4.0. Styracosaurs, expected 18, found 18, version 3.9. Microceratops, expected 22, found 22, version 4.1. Total, expected 238, found 238. "What you see here," Arnold said, "is an entire separate counting procedure. It isn't based on the tracking data, it's a fresh look. The whole idea is that the computer can't make a mistake because it compares 2 different ways of gathering the data. If an animal were missing, we'd know within 5 minutes.
"I see," Malcolm said. "And has that ever actually been tested?"
"Well, in a way," Arnold said. "We've had a few animals die. An Othnielian got caught in the branches of a tree and strangled. One of the stegos died of that intestinal illness and keeps bothering them. One of the hypsilophodontids fell and broke his neck.
and in each case, one of the animals stopped moving, the numbers stopped tallying, and the computer signaled an alert.
Within 5 minutes?
Yes, Grant said. What is that right-hand column? Release version of the animals. The most recent version, 4.1 or 4.3. We're considering going to version 4.4. Version numbers? You mean like software? New releases? Well, yes, Arnold said. It's like software, in a way. As we discovered the glitches in the DNA, Dr. Wu's labs have to make a new version. The idea of living creatures being numbered like software, being subjected to updates and revisions, troubled Grant. He cannot exactly say why. It was all too new a thought, but he was instinctively uneasy about it. They were, after all, living creatures. Arnold must have noticed his expression because he said, Look, Dr. Grant, there's no point getting starry-eyed about these animals. And it's important for everyone to remember that these animals are created. Created by man. Sometimes there are bugs. So as we discover the bugs, Dr. Wu's labs have to make a new version, and we need to keep track of what version we have out there.
Yes, of course you do, Malcolm said impatiently. But going back to the matter of counting, I take it all the counts have been based on motion sensors.
Yes.
And these sensors are everywhere in the park?
They cover 92% of the land area, Arnold said. There are only a few places we can't use them. For example, we can't use them on the Jungle River because the movement of the water and the convection rising from the surface screws up the sensors. But we have them nearly everywhere else. And if the computer tracks an animal into the unsensed zone, then it'll remember to look for the animal, come out again, and if it doesn't, it gives us an alarm.
Now, then, Malcolm said, you show 49 proconsubnthids. Suppose I suspect that some of them aren't really the correct species. How would you show me that I'm wrong?
2 ways, Arnold said. First of all, I can track individual movements against the other presumed compies. Compies are social animals. They move in a group. We have 2 compy groups in the park, so the individual should be within either Group A or Group B.
Yes, but...
The other way is direct visual, he said. He punched buttons in one of the monitors, began to flick rapidly through images of compies, numbered 1 through 49.
These pictures are...
current ID images, from within the last 5 minutes.
So you can see all of the animals if you want to.
Yes, I can visually review all the animals whenever I want. How about physical containment? Gennaro said. Can they get out of their enclosures? Absolutely not, Arnold said. These are expensive animals, Mr. Gennaro. We take very good care of them. We maintain multiple barriers. First, the moats. He pressed a button, and the board lit up with a network of orange bars. These moats are never less than 12 feet deep and water-filled. For bigger animals, the moats may be 30 feet deep. Next, the electrified fences. Lines of bright red glowed on the board. We have 50 miles of 12-foot-high fencing, including 22 miles around the perimeter of the island. All the park fences carry 10,000 volts. The animals quickly learn not to go near them. But what if one did get out? Gennaro said. Arnold snorted and stubbed out his cigarette. Just hypothetically, Gennaro said. Supposing it happened. Muldoon cleared his throat. We go out and get the animal back, he said. We've lots of ways to do that. Taser shotguns, electrified nets, tranquilizers. All non-lethal because Mr. Holland says these are expensive animals. Gennaro nodded. And if one got off the island? It'd die in less than 24 hours, Arnold said. These are genetically engineered animals. They're unable to survive in the real world. How about this control system itself? Gennaro said. Could anybody tamper with it? Arnold was shaking his head. The system is hardened. The computer is independent in every way. Independent power, independent backup power. The system does not communicate with the outside, so it cannot be influenced remotely by modem. The computer system is secure. There was a pause. Arnold puffed his cigarette. Hell of a system, he said. Hell of a goddamn system.
Then I guess, Malcolm said, your system works so well that you don't have any problems.
We've got endless problems here, Arnold said, raising an eyebrow. But none of the things you worry about. I gather you're worried that the animals will escape and will get to the mainland and raise hell. We haven't got any concern about that at all. We see these animals as fragile, as delicate. They've been brought back after 65 million years to a world that's different from the one they left. The one that they're adapted to. We have a hell of a time caring for them. You have to realize, Arnold continued, that men have been keeping mammals and reptiles in zoos for hundreds of years. So we know a lot about how to take care of the elephant or a croc, but nobody tried to take care of a dinosaur before. These are new animals, and we just don't know. Diseases in our animals are the biggest concern. Diseases? Jar said, suddenly alarmed. Is there any way just that a visitor can get sick? Arnold snorted again. You ever catch a cold from a zoo alligator, Mr. Gennaro? Zoos, don't worry about that. Neither do we. What we do worry about is the animals dying from their own illnesses or infecting other animals, but we have programs to monitor that too. Want to see the big Rex's health file? His vaccination record? His dental record? That's something you ought to see the vet scrubbing those big fangs so he doesn't get tooth decay. Not just now, Nora said. What about your mechanical systems? You mean the rides? Arnold said. Grant looked up sharply. Rides? None of the rides are running yet, Arnold was saying. We have the Jungle River ride, there are boats follow tracks underwater, and we have the Aviary Lodge ride, but none of it's operational yet. The park will open the basic dinosaur tour, and the one that you're about to take in a few minutes. The other rides will come online 12 months after that. Wait a minute, Grant said. You're gonna have rides, like an amusement park? Arnold said, This is a zoological park. We have tours of different areas, and we just call them rides, that's all. Grant frowned. Again he felt troubled. He didn't like the idea of dinosaurs being used for an amusement park. Malcolm continued his questions.
You can run the whole park from this control room?
Yes, Arnold said. I can run it single-handed if I have to. We've got that much automation built in. The computer by itself can track the animals, feed them, fill the water troughs for 48 hours without supervision.
This is the system Mr. Nedry designed?
Malcolm asked. Dennis Nedry was sitting at a terminal in the far right corner of the room, eating a candy bar and typing. Yes, that's right, Nedry said, not looking up from the keyboard. It's a hell of a system, Arnold said proudly. That's right, Nedry said absently. Just one or two minor bugs to fix. Now, Arnold said, I see the tour is starting, so unless you have other questions...
Actually, just one, Malcolm said. Just a research question. You showed us that you can track the proconsubthids, and you can visually display them individually. Can you do any studies of them as a group? Measure them, or whatever? If you want to know the height, or...
Arnold was pushing buttons. Another scream came up. We can do all of that and very quickly, Arnold said. The computer takes measurement data in the course of the reading the video screens, and so it's translatable at once. You see here we have a normal Gaussian distribution for the animal population. It shows that most of the animals cluster around the average center value, and a few are either large or smaller than the average at the tails of the curve.
You'd expect that kind of graph,
Malcolm said. Yes, any healthy biological population shows this kind of distribution. Now then, Arnold said, lighting up the cigarette. Is there any other questions?
No, Malcolm said. I've learned what I needed to know.
As they were walking out, Jannar said, Looks like a pretty good system to me. I don't see how any animals can get off this island.
Don't you? Malcolm said. I thought it was completely obvious.
Wait a minute, Jannar said. You think animals have gotten out?
I know they have.
Jannar said. But how? You saw for yourself. They can count all the animals. They can look at all the animals. They know what the animals are at times. How can they possibly escape? Malcolm smiled.
It's quite obvious, he said.
He said.
Just a matter of your assumptions.
Your assumptions?
Malcolm smiled. It's quite obvious, he said. It's just a matter of your assumptions.
Your assumptions? Jannar repeated, frowning.
Yes, Malcolm said. Look here. The basic event that has occurred in Jurassic Park is that the scientists and technicians have tried to make a new, complete biological world. And the scientists in control room expect to see a natural world, as in the graph they just showed us. Even though Memma's thought reveals that nice, normal distribution is terribly worrisome on this island.
It is?
Yes. Based on what Dr. Wu told us earlier, one should never see a population graph like that.
Why not? Jannar said.
Because that's the graph of a normal biological population, which is precisely what Jurassic Park is not. Jurassic Park is not the real world. It is intended to be a controlled world that only imitates the natural world. In that sense, it's a true park, rather like a Japanese formal garden. Nature manipulated to be more natural than the real thing, if you will.
I'm afraid you've lost me, Jannar said, looking annoyed.
I'm sure the tour will make everything clear, Malcolm said.